Hello everyone, and welcome to today's live broadcast, Better Safe Than Sorry, Safety and Maintenance for Benchtop Centrifuges, presented by Nicole Seeligmüller, an application specialist sample handling at Eppendorf AG. I'm Susie Valdez of LabRoots, and I'll be your moderator for today's event. We're delighted to bring you this educational web seminar presented by LabRoots and sponsored by Eppendorf. Eppendorf is a leading life science company that develops and sells instruments, consumables, and services for liquid, sample, and cell handling in laboratories worldwide. Before we begin, I'd like to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. Just click on the green Q&A button located at the lower left of your presentation window. Type your question into the box that appears on the screen, and we'll answer as many questions as we have time for at the end of the presentation. Also, you'll notice that you will be viewing this presentation in a slide window. If you'd like to enlarge that window, just click on the screen icon located on the lower right. If you have any trouble seeing or hearing this presentation, click on the support button at the top right of the presentation window, or use that Q&A button and let us know you're having a problem. Good news, this presentation is educational and thus offers continuing education credits. Please click on the button in the bottom left-hand corner and follow the process for obtaining your credits. I'd now like to introduce our presenter, Nicole Seeligmüller. Since 2015, Nicole is responsible for applications regarding centrifugation, as well as customer support and trainings at Eppendorf in Hamburg. Previously, she worked several years as a sales representative, offering the best solutions for molecular and cell biology for her customers. During her studies at RWTH Aachen, Germany, she acquired a broad spectrum of methods in the field of biology. Furthermore, she earned a strong knowledge in medical microbiology during her diploma thesis in 2010 at the Institute for Veterinary Medicine at FU Berlin in Germany. Please join me in welcoming her, Nicole Seeligmüller. Welcome, Nicole.
Thank you, Susie. Yes, and welcome everyone. I'm really happy to see that we are a big group of attendees today. And yeah, let's not waste time and start with the presentation. Better safe than sorry, safety and maintenance for centrifuges. So, well, we will have a little structure here. I will talk about some basics, about centrifugation in general. Then I will come to talk about some safety aspects. I will show you some centrifuge or accessory damages, so you can easily recognize if you have a problem with your equipment or not. And afterwards, I will give you some practical tips about cleaning and maintenance of centrifuges. So yeah, let's start. Well, scientists know that centrifuges are important tools in the daily laboratory work. But also for those who are not working in a laboratory environment, centrifuges are a part of the daily life. And surely not everyone has something like that, a cream separator at home, but most of us do own a washing machine, I think. Here, the centrifugal force helps to separate water and clothes at the end of the washing process. And also, most of us have experienced the G-force during a run on the aeroplane or even a roller coaster. Yeah, centrifugal forces are even essential to produce foods most of us have in our kitchens, like olive oil or honey. And to harvest the honey, for example, the beekeeper removes the frame that houses the honeycombs from the hive and places it upright into the honey separator, where the centrifugal force will pull the honey from the combs. Okay, now that we know we all have centrifuges, let's put first things first. Which forces are reached in centrifuges? To understand the importance of the safe handling, we will use our Eppendorf Centrifuge 5810R as an example. The swing-out rotor S4104 enables up to 3146 G. Loading 4 full 750 ml bottles into the buckets means that the load per bucket is around 1 kg, so 1,050 grams, sorry. So 4.2 kg in total. 4.2 kg spun at 3,146 G equates 13,213 Newton, which equates 1,347 kg, the average weight of a middle-class car. So yeah, quite impressive. We see that due to the acceleration up to 3,146 G, the weight of the samples does increase rapidly, and therefore it is necessary to pay attention to a safe working practice when it comes to centrifugation. So this example here only shows the forces during an average run in a swing-out rotor, which is quite slow in comparison to fixed angle rotors or even floor standing and ultracentrifuges. Well, now that we've talked about the forces that can be reached in centrifuges, let's see what can happen in the worst case. This picture shows a destroyed ultracentrifuge at the Purdue University in Indiana. And yes, surely this is an incident which will not happen this way with the normal benchtop centrifuge, due to several reasons I will explain in a bit. But the possibility of a rotor crash is always given when the centrifuge is operated in an incorrect way, leading to the failure of the rotor and possibly the centrifuge as well. And even if the environment is not harmed, like in the picture, your samples and your instrument will be. Susie will be, so would you be so nice to send out the link for the video, because I have prepared a little video where you can see an actual crash test for a centrifuge. Because the question is, how can we feel safe while spinning samples? Well, all benchtop centrifuges must fulfill several guidelines to gain the so-called CE certificate. And one of them is the guideline EN 610102020. You don't have to remember that anyway. The crash-resistant construction of the chamber. So the crash resistance of the chamber must be proved via a rotor crash test, which you can see in the video. And during this test, a rotor crash is induced. And the test is passed if the centrifuge stays intact, so nothing getting out or causing local buckling or anything. And additionally, the centrifuge must not move more than 30 centimeters in each direction during the crash. This is why there's this line around the centrifuge. And this is also the reason why every manufacturer suggests to keep about 30 centimeters free space to all sides of the centrifuge. And yes, because of the exhaust air needs to flow freely. And yeah, if you're interested, you can take a look in this video and see how this crash test takes place. Right. So talking about some more basic information, let's talk about parameters, especially RPM versus RCF. In many protocols, it is still usual to use RPM, so revolutions per minute, in contrast to RCF, which is the relative centrifugal force, to describe the speed. But RPM specifies the number of rotations around the fixed axis in 1 minute, without taking the radius, so the distance from the center of the rotor to the most exterior point of the rotor. And this distinction between RPM and RCF is important because two rotors with different diameters running at the same rotational speed, so RPM, will result in different G-forces. And we will see this in a little example here. Comparing the Mini-Spin Plus and the Centrifuge 5427R, we see that both centrifuges are running at the same speed, which is 14,000 RPM. But looking at the radii, we see that the radius of the rotor of the Mini-Spin is only 6 centimeters, whereas the radius of the rotor in the 5427R is 10.1 centimeter. And using this tiny little basic formula, you don't have to use that because we will come later on to a point where you can see it's quite easy to get to the RCS if you only have RPM. If we use this formula, we will see that in the Mini-Spin Plus, the same RPM results in 13,150 G, whereas with a bigger radius, so a bigger rotor, the same RPM leads to 22,132 G, which is quite a bit of a difference. And this means that a protocol which only gives the RPM value needs to specify which centrifuge and rotor was used. And otherwise, results are not comparable because different rotors can lead to different pelleting results. Yes, that was all about the basics. Let's get a bit deeper into safety aspects. Adapters. I think everyone, especially using the bigger benchtop centrifuges, is quite familiar with adapters. But why do I need them? Well, benchtop centrifuges can accommodate a wide range of vessels, starting from very small volumes like 0.2 up to 2 ml tubes, which are preferential spunnet in small benchtop centrifuges, to blood collection tubes or HPLC and cryo vials, round bottom tubes, conical tubes, whatever you can think of, and even bigger volumes like bigger conical tubes or even 1,000 ml bottles can be spun nowadays in benchtop centrifuges. And to accommodate all these different vessels, most of the times adapters are needed. They offer the flexibility to spin a wide range of tubes in just one or two different rotors. The adapter concept means that there are different adapters available in the market. Adapters can be made of one piece, the so-called monoblock adapters, as well as modular adapters, which can be divided into two or more parts adjusting to the vessel length. And there are different adapters also available supporting the vessel bottom shape, like conical skirted or flat bottom shapes. As you can see in the picture here, we do have an example for the modular system. You can see that at least 2/3 of the tube should be supported. So if you're using modular system adapters, please do not just support the vessel bottom, because this can lead to tube breakage. And we do also have adapters, or the manufacturer of your used vessel has adapters supporting the bottom shape of your vessels, especially for larger conical vessels like 200, 250 ml conical vessels. The manufacturer usually provides the so-called cushions for their bottles, so you can spin them in your centrifuge. And if you are not sure actually which adapter would be the best fit for your vessel, because I am quite sure that sometimes it's not an easy job to find the perfect one, just contact your centrifuge manufacturer. I think they will be happy to help. So we have been talking about radius just a few slides before. The question is, why should I set the radius actually? And as explained earlier, the radius is important for the correct definition of the G-force. Using adapters can lead to a change in the radius, especially when you're using adapters which are shortening the radius. So in the picture here, you can see radius 1, where the vessel is at the bottom, so at the most exterior point of the rotor. But when you use an adapter like here, where the vessels in green are not at the most exterior point of the rotor, the radius will change. And in this case, it is recommended to set the correct radius, and most centrifuges will offer this function in their menu. to make sure that the samples will be spun at the desired G-force. Yeah. And it's not only about adapters, it's also about the correct rotor loading. So even without vessels, there are still some things to think about when loading your centrifuge. We do have 4 examples here where a rotor is loaded completely wrong. I'm quite sure that nobody would ever do this way, but I just wanted to point out in a more drastic way to what can be done wrong. So as you can see here, it should be equally loaded, and especially with swing-out rotors, it's necessary that all rotor arms are loaded. And for the microcentrifuges, you can see an example here how you load the Eppendorf tubes correctly in your rotor, or how to load a swing bucket rotor for conical tubes. You can also, on our Eppendorf homepage, find a centrifuge maintenance poster where you have a lot of examples actually how to load your rotor in the correct way. So it's not that hard, but yeah, I just wanted to make sure that this is also heard. Well, looking at swing-out rotors, there are a couple of things more to keep in mind. Because, as I said, it's very important that our bucket slots are occupied with buckets during the run, because spinning a rotor cross with empty bucket slots would lead to bended rotor arms due to the centrifugal forces. And also, you should make sure that the buckets swing out smoothly via a manual swing out test, as you can see here in the picture. Because, yeah, there you can see if your tube fits and it doesn't touch the rotor cross, and also if it doesn't swing out properly, it is probably time to apply grease in the grooves and the pivots. So, yeah, these are just some tiny things to consider when using swing-out rotors. Also, it's necessary to have the balance point in the middle of the bucket. Yeah, what does that mean? We do have swing-out rotors for plates here in the picture. And if you spin plates, you should always keep in mind to fill the plates only 2/3 of the total volume. So not the total volume of the plate, but the well. And for a proper swing out, when they're loaded lengthwise, so as you can see, if they would swing out like this, when the rotor is in the middle, the heavier part would be on the outside where the wells are loaded. And you should make sure that it's done correctly, because the balance point is also something you should keep in mind to prevent your plates and buckets swinging out in the wrong direction, actually. If not working with plates, but also with the swing-out rotor, there are differences here. You can see here buckets loaded with tubes, and as you can see, the pivots are not loaded equally, because the tubes are always also, all of the tubes, sorry, are put into on one side. So that means one pivot is carrying all the weight, and it's important to load them equally because this reduces vibrations and noise and stress for the centrifuge rotor and motor. So as you can see here, in this example, our pivots are loaded equally and the weight is balanced quite well between the two. Rotor load, also something which should be considered. Because rotors are, looking at their physics, there's a point where things can get too heavy, because we have learned in the second slide, during the centrifugation run, things can get quite heavy. And the maximum weight, loading weight, is usually printed on the rotor. And this includes the bucket weight, the adapter weight, and the weight of flask and sample. Here we can see we have a maximum loading weight of 4 times, so for every bucket, 1.1 kg. It's usually printed on the rotor. And also buckets can have weight classes. Sometimes they're indicated with a number, sometimes they're indicated with just a letter, but usually they have weight classes, and these must be accommodated on opposite positions, so we have an equal weight on each side of the rotor. Yeah, so we're halfway through. Let's have a look at some centrifuge damages, or not centrifuge damages, it's more damages of the equipment. So you can maybe learn a little bit about when to talk to a service engineer, or just to replace your equipment. Talking about rotor lids, we can have plastic rotor lids, for example, and as you can see here in the picture, they can have scratches, and then they need to be replaced because they can break during the run. To prevent scratched rotor lids, you should ensure that they fit safely on the rotor lid before the run, because these scratches usually develop when the rotor lid is not fixed completely, and then it's getting loose during the run, and then it just flies somewhere, and it's not quite good. Some rotors do have windshields, as you can see here in the picture. This windshield is just for the to reduce noise and to protect your samples a little bit. They can get damaged as well if they fall down, and if they bang against surfaces or anything. And we would recommend to replace them as well when they're bent or something, because they can cause vibrations during the run, and this can cause midterm damages of the drive in the end, and I don't think anyone wants that. So this is about rotor lids. Looking at the rotors themselves, we can have light scratches on the rotor surface, as you can see here. This is not a direct reason to get rid of your rotor immediately. You should continue to monitor your rotor to detect corrosion, because these scratches meaning that the protecting alloxated surface of your rotor is gone, and that there are places where corrosion could grow. And to prevent scratches on your rotor surface, try to avoid banging and dropping of the rotors, and especially never use metallic cleaning tools. I will show you later on suited cleaning tools for your equipment. We can also have scratches inside of the rotor lid after cleaning, for example. As you can see here, this is the inside of a aluminum rotor lid. If you use metallic cleaning tools, this can be the result. And you should check them. You should continue monitoring and only use a soft cloth for cleaning of your rotor lids and your rotors as well. We can have damages of the rotor cone. So if you turn your rotor upside down, you can see the rotor cone. This is usually the part where it sits on the motor shaft. And sometimes, if you're in a hurry, or you don't really pay attention, then it can be the case that this part hits the motor shaft, leading to these little damages. The area should be checked for gouges, and if necessary, should take the rotor out of service, because this is an important area here too, even though it's quite underestimated most of the times. And you should really pay attention to always assemble and remove the rotor straight from the top, and to avoid any angle or bending or something like that, and then everything should be fine. Well, talking about rotor cones, the opposite part, the motor shaft and the centrifuge, where the rotor cones sit on, this can be bent, because of the same reason. If you don't set up and lift the rotor in a straight up motion, or if there are angles or whatever, then yeah, the motor shaft can bend, and this is where you should definitely send your centrifuge to service, and then just the shaft can be exchanged. Also, you should always make sure that your samples are balanced symmetrically, because due to imbalances, this part of the centrifuge can get damaged in midterm run. Yeah, we can have gouges on the outer rotor surface, which is like a really deep scratch. You can see it in a picture here. This is a reason to replace the rotor, because it's a very deep scratch, and this can actually, in the worst case, lead to a rotor crash. And yeah, I would avoid to spin the rotor in that state. We can also have a damaged thread of a fixed angle rotor lid. So this is the again the downside of a aluminum rotor lid. When you screw this lid onto the rotor, and it's a bit hard, sometimes people tend to yeah, push it, or to use a higher force to just properly screw the lid on the rotor, but this can result in these little damages. And then I would recommend to replace the lid and always use the same lid for the same rotor. Usually rotors come with a lid. And yeah, clean and, for example, lubricate these threads regularly. I will talk about lubrication a little bit later. Oopsie, there's already a mark. Let's see what, okay. So we have bucket grooves, swing out buckets. This is a plate bucket here. Also, when you place these buckets on the pivots, you should pay a bit of attention to not bang them, because this can also lead to damage. And I would then suggest to replace the buckets. Usually you should replace them pairwise due to the weight class. And we can also have damages not only on fixed angle rotors, but also on a rotor cross of a swing out rotor, as you can see here. And this is also something where I would recommend to continually monitor your rotor cross, and if these damages get bigger or deeper or whatever, I would recommend to replace the rotor. And how to prevent damages like this is easy, just as I suggested a couple of slides before. If you're using new tubes, where you're not sure if the tube is not too long for the rotor, just perform a manual swing out test before spinning it, and then you can, this way you can make sure that the tubes won't touch the rotor cross during the spin. You don't have to do this every time if you use the same tubes forever and ever, but if you switch, then I would recommend the manual swing out test. Yeah, a lot of people in the lab are working with DNA or RNA extraction kits, and from them we can see that there are sometimes salt incrustations which can lead to corrosion. So here's a picture of salt crystal debris on a rotor surface. From my side, I was working in the laboratory a lot with extraction kits, and usually rotors look like this. This is something which can be prevented by just regular cleaning, especially when a tube breaks. As you can see in the second picture, this is a lot of residue from salt. Don't let this dry and stay on your rotor. Just take a moist cloth and wipe it away. This will prolong the rotor lifetime. We can have the same in buckets as well. Here's an example of a swing out bucket where customers were working with salt buffers, and yeah, as you can see, there were like tube breakages, and the residue was left in the bucket, and over the time the salt crystals can eat into the material, which can, if you keep these buckets for a long time, lead to a weak spot in the bottom of the bucket. So I would recommend to clean afterwards, and if you see buckets like those, replace them, because you risk corrosion and you risk a rotor crash in the worst case. We can have also advanced corrosion. If you don't clean and you don't care, you might see something like this. It's like a see-through rotor borehole, and it's a complete hole in the rotor, which is actually not funny, because these spots can result in a rotor crash. That's what I meant with the worst case. If you see a rotor like this, please get rid of it, and because there is nothing left to clean or to repair or anything. It's just a risk for your equipment. Okay, so these were some examples for centrifuge or centrifuge equipment damages. I know they look quite dramatically, and not every lab, I think, will have this problem. They were just examples of how equipment can look like and what should be considered and what you can do is something we will talk about now in cleaning and maintenance part. So the manual cleaning procedure for a centrifuge is as follows. You should clean and dry a centrifuge chamber after each run. This would be the perfect world. You can do it at the end of the day, and especially the lid should be remaining open overnight to let, for example, if you're working at 4 degrees, there will be a little ice buildup in the centrifuge. And so when you leave the lid open overnight, this can dry and just evaporate. You can use a soft cloth to clean the centrifuge housing, the chamber, also the rotor shaft, rotor and rotor lid and caps. So no metallic cleaning tools, just a soft moist cloth. You can use neutral cleaning agents like soap, or if you want to disinfect, ethanol. And if you have salt incrustation, as we have seen a couple of slides before, maybe a tube broke or something, then clean the chamber and the rotor immediately after the run. Just water, neutral agent, neutral cleaning agent, and a soft brush. You can also fill the boreholes with water, because usually the most of the content of the tube will be in the boreholes. And you can fill them with water to clean them, but you should not dip the rotor completely in water, because the rotor has openings like from the like as you have seen with the rotor conus, and water can get into the rotor and it might remain in the openings. And this can then, if the water stays still in there, lead to little imbalance problems. So please do not dip the rotor in water. And you can dry it with a soft cloth. As you can see in the pictures, it's not a lot of work. It just should be done regularly. If we have a tube breakage, and the risk of contamination, because we're working with infectious samples, for example. There are a couple of more things you should consider. You should always wear a lab coat. I know everyone is doing that in the laboratory. Gloves and protective goggles during the decontamination process. As you can see here, it's an example. Let's say this is blood and it was spilled in your centrifuge, and you've been working with glass tubes. If you have broken glass pieces, then retrieve the bigger pieces with forceps and small and powder shards can be removed with a damp, lint-free cloth. Yeah, you can absorb the spilled sample with gauze or just a paper towel and then seal the infectious material in a biohazard bag, so you can just dispose it afterwards. Then wipe the contaminated parts with distilled water, or you can use soaked gauze or a lint-free cloth. Yeah, the contaminated rotor can be removed from the centrifuge then, and then you can wipe the parts you cannot really reach if the rotor is still in the centrifuge, and then you can clean the rotor and everything and wipe it with a cleaning agent or, for example, 70% ethanol. And if necessary, you can also autoclave your equipment at usually 121 degrees for 20 minutes. So yeah, I have promised I will tell you something about cleaning tools that can be used. So allowed are plastic scrub pads if you have stubborn contamination, or a stiff brush with end bristles, and very important, a non-metallic tip. So you can have these brushes with just plastic tips. You can use that for the boreholes, for example. And you shouldn't use steel wool. You shouldn't use abrasive cleaning agents. Yeah, brushes with metallic parts, or even completely made of metal, and other abrasive, oops, going back to that, sorry. Abrasive. Just keep in mind, maybe think of your car and then think of, would I use that to clean my car, because it's quite delicate. And then, yeah, I think it's quite clear what to use and what not. Okay, dishwasher. You wouldn't put your car in a dishwasher, won't you? And so please don't put your rotors in a dishwasher, because this will be the result, because the salts used in a dishwasher can remove the alloxated surface of the rotors, and this can lead to corrosion, and then the corrosion can grow, it can cause fatigue or holes even, and then a continued operation is dangerous. So I'm sorry, but no dishwasher for rotors, not for buckets, and not for rotor crosses. But I'm totally fine with putting adapters in the dishwasher, so maybe some little relief. Okay, disinfection. We've been talking about cleaning. Now let's talk about disinfection, especially when you work with infectious or samples like bacteria, whatever. You probably would like to disinfect your equipment, your centrifuge, but there are some things to consider. Please do not use UV, beta, or gamma radiation or any other high-energy radiation source for the disinfection, because this can harm your equipment. Also, I don't recommend gaseous disinfection of the machine, of your centrifuge itself, by aerosols, so like hydrogen peroxide or similar agents. The equipment is fine, so you can disinfect the rotor or buckets or even the rotor crosses with gaseous hydrogen peroxide, but please not the machine. And yeah, we do offer a user manual. There are a lot of instructions in there as well if you have questions. You can always ask your distributor if your disinfectant is suitable. So if you're probably working with a special disinfectant, just let us know and we can say, yes, we've tested that with the material and everything's fine. Or we can even recommend whatever. You can find an example here. So there's quite a lot of disinfectants we have tested them with different materials of our Eppendorf equipment, and you can see this is an overview what you can use. This can also be found on our homepage. We have a complete white paper about it. It's called White Paper 14. And yeah, it's also easy to download on our Eppendorf Centrifuge section. Yeah, last but not least, autoclaving. Also, yeah, necessary to sterilize your equipment. The rotors can be autoclaved at, as I said, 121 degrees for 20 minutes, except especially coated rotor crosses. These can be sterilized with gaseous hydrogen peroxide, as I said. There are also special rotors on the market which can be autoclaved up to 135 or even 142 degrees, especially for those of you working with prions. And yeah, you just should remove the lid from the rotor, as you can see in the picture. Just put it next to the rotor, but don't yeah, let the lid be attached during the autoclaving run. And yeah, lubrication, I promised. We do have our centrifuge grease. If you were ever wondering when ordering a rotor and there's a little white tube coming with it, this is a centrifuge grease. You can use it to lubricate the rotor chamber seal, for example. This is made of rubber, and when it gets a bit older, it can get a bit dry. It's like skin, as you can maybe imagine, and then just lubricate it after cleaning. You can also lubricate the pivots of the swing-out rotors and the bucket grooves, especially when you have the feeling that you balance your samples quite well, but it's still a little bit, yeah, a little bit of vibration. This might be the reason. So just put a little bit of grease on there. Also, the threads of fixed angle rotors can be lubricated. So if the rotor lid is hard to close or to open, this can help. You can also put a little bit of rotor grease on the rotor surface. That can also prolong the rotor lifetime. And do not lubricate the motor shaft or the rotor conus, so the bottom side of the rotor, because these are parts which should be dry, and when you grease that, there might be the risk of yeah, that the rotor is not properly fixed on there, and because of that we don't want that to be greased. But the rest is fine, as you can see here in the examples. Okay, so this was everything from my side. I want to say thank you for your attention. If you want to have more information about centrifuges, applications, whatever you can think of, we do have a new website, our sample handling website. Susie will send out a link for you in a bit. If you want more information, just pop over there and have a look around. And yes, so now I'm open for your questions and happy to answer some of them. I think we have quite a bit of time left, so let's have a look.
Nicole, thank you so much for your informative presentation. And we will now start that live Q&A portion of the webinar. We have a fantastic audience today. Just remember, if you'd like to ask a question, please do so now. Just click on the green Q&A button at the lower left of your presentation window. Type that question into the box that appears on the screen and click the send button. We're going to answer as many questions as we have possible for today. So let's get started with our first set of questions. Our first audience member would like to know, Nicole, after centrifuging samples at low temperatures, like 4C or lower, condensation will build up inside the centrifuge. what are your recommendations for drying it out? Is leaving it open fine, or is dust a concern?
No, I don't think that dust is a concern here. So at the end of the day, I would just recommend to, so if you have, for example, a little bit of ice buildup, what you can do is also like a short run at, let's say, 30 degrees. So just set your centrifuge to 30 degrees, do like a 10-15 minute run. This will melt everything, and when you then open the centrifuge and let everything evaporate, it's a quicker way. But if you have the time to just open your centrifuge, to leave it open overnight, maybe wipe it out before you leave the laboratory, that's fine. And no, dust is no concern. You don't have to worry about that. All right.
Our next audience member would like to know, you just talked about salt incrustations on rotors from DNA and RNA kits. I have such salt deposits, but wiping with a moist cloth doesn't always help. The salt is too encrusted. Can we clean the rotor with a plastic dish brush or something equivalent?
Yes. As I said before, everything made of plastic. You can also use a little plastic brush. I haven't shown these brushes. You probably know them from your kitchen, for example, from the dishwashing part. You can just use them to try to remove the residues. The only thing you should really keep in mind is to not use metallic cleaning tools, but the rest is fine. Yeah.
And Nicole, here's a related question. How would someone avoid leaks in those rotors or anywhere while centrifuging?
Leaks in rotors, you mean probably leaks in the vessels you use. So what I recommend is to consider there's usually a maximum and minimum filling volume of your tube. So tubes shouldn't be filled more than 80%, because after more than 80%, especially with swing out rotors, the liquid can touch the thread of the vessel. And if the tube is not correctly closed, then these can lead to leakage. Or, for example, if the maximum speed recommendation for your tube, usually some, like conical tubes, some of them are centrifugeable up to 5,000, others are usable up to 19,000, for example. You should always consider this as well. If you spin your tubes at a too high speed, they might break, and this is something you can really prevent.
Great, thank you. You know, we have an incredible audience today, very captivated, and we have a lot of questions coming in. Here's another related question, I think. We have a 5,424 centrifuge. Because it was a bit dirty, I wanted to take the rotor out, but it wasn't quite possible. After unscrewing it, it wouldn't come off the shaft. Should that be possible?
Well, usually it should be possible to remove the rotor. Sometimes if you don't clean it for a while, then the rotor can be stuck. Sometimes it helps to have like a strong man. Sometimes you have to have a strong man called service technician to remove the rotor. So I wouldn't recommend to put like high forces on the rotor and try to remove it when it doesn't want to be removed. Maybe it's stuck in there, and so I would recommend to ask a service technician for help, actually.
Great, thank you. Here's a question from across the world. What method would you recommend for safely measuring the RPM/RCF on a centrifuge that does not have a tachometer window? Tachometer.
Tachometer window. So it's probably quite a old centrifuge. Well, that's really hard. I mean, yes, service technicians, they have the tools to measure the speed, while they have special tools for that. But yeah, I don't think that there is a very safe way to measure that if you have just like in a car, the tachometer without digits. So yeah, I don't really see a perfect way to perfectly measure this. I mean, if you have an old centrifuge just saying RPM, and you really want to know what is the RCF, then this is possible. So you can actually take the radius of your rotor. If you don't know the radius, you should ask your manufacturer for the radius of your rotor. And then there's, for example, on the website I've just recommended, the sample handling website from Eppendorf, there's an RPM RCF calculator. And if you put in there the RPM and then the radius of your rotor, it will come up with the RCF. So we cannot really control every centrifuge is spinning at the right speed, but we can definitely help you to calculate the RCF if you only have RPM.
Great, thank you. I want to thank our audience again for such an active participation. Our next question comes from an audience member saying, I think bucket caps are useful added containment when working with infectious or hazardous materials. Does Eppendorf plan to make these bucket caps standard accessories with all centrifuges?
Yeah, we do not only plan this. I think that's in 95% of our rotors already the case. So for example, all of our fixed angle rotors coming with a red knob, that means that they are aerosol tight, and we're shifting more and more towards producing aerosol tight rotor lids. So if you have an older centrifuge like 5417, for example, there are non-aerosol tight lids on there, but all newer machines and every centrifuge that will be released in the future, they will all give the user the possibility to use aerosol tight caps and lids, definitely, yes.
Great. Our next question is, why should I look for an automatic rotor recognition in my centrifuge?
It's a safety thing. So if you, for example, have personnel like students or interns in your laboratory and they're not quite familiar with how to load the rotor properly, it might be the case that someone is spinning the centrifuge with an unbalanced rotor, which can lead to some problems if the centrifuge doesn't shut off automatically. So an automatic imbalance recognition means that the centrifuge is built in a way that it can detect an imbalance and trigger a kind of emergency shut off before there will be damages or incidents during the run. So if the centrifuge recognizes there's an imbalance, it will shut off the run and will break, and then it will give you a message, imbalance, and then you should properly balance your samples again. It's just to protect you and your centrifuge as well.
Thank you so much. Does a centrifuge need a regular calibration?
No. Well, all of our centrifuges, I'm just talking about benchtop centrifuges now. I cannot talk, for example, for ultra centrifuges, but they don't need calibration. If you want to, and if you're working in a regulated area, then you can have the service technician coming like once a year doing a OQ, for example. But this is not necessary. If you want to spin and just to work and whatever, you can use your centrifuge as long as you want without having someone coming over to check it. The parameters all should be fine, so there's no need for a regular calibration. It's not like a car where you should go to have it checked from time to time.
Wonderful. Again, thank you so much to our audience members. Our next question, you talked about balancing rotors, but it is fine to do mixed loading in swing bucket rotors, right? And it's actually a two-part question. That's the first part. Like 15 milliliter conical tubes across from each other and 50 ml conical tubes across from each other. Does mixed loading like this reduce the life of the rotor? I hope that makes sense.
Yeah, I understand what you mean. Well, there are some rotors made for this. So if you have 15 and, for example, 50 ml mixed bucket loading, the only important thing is that the buckets opposite of each other are balanced. But you can also spin with the dedicated, so not all rotors can do this, but the rotors which can do this, they are marked. So we definitely tell you that these are rotors which can do mixed bucket loading. And then you can spin like 2 plates opposite of each other and then like 50 ml conical tubes at the 2 other places, but this is fine. We have tested these rotors under these circumstances, and therefore it's completely fine. You only have to make sure that everything opposite of each other is balanced well.
Great, thank you. Our next question is, my lab uses and stores our microfuge in our biological cabinet. Each day and between different types of samples, we UV the biological cabinet. With the top closed on the microfuge, would the UV still damage it, or is this only when it is open? When it is opened, the rotor directly exposes the the UV.
So I think you've been talking about the what I said, high energy radiation, like UV, beta, whatever. This is more due to the material. So it will be fine for the rotor, but since, as you can imagine, plastic, for example, will age during it will age due to UV light, and so our equipment is fine with the normal UV light. It shouldn't be set up where there is direct sunlight all the time, because this will heat up the machine. But it's more a matter of material and material aging when there is a higher amount of UV light on the centrifuge surface. And I'm not quite sure if we have done tests for long exposure to disinfection UV light. I think I would need to check that and come back to you via email. Because right now I cannot speak for every centrifuge here. So yeah, but I will definitely check. I am quite sure that our material is really robust and that it should be fine for a while. But if you do this for like 10-15 years, then I am not sure what would happen to the material in long-term run.
Great, thank you so much. We have time for a couple more questions, and I want to remind the audience members that the questions that weren't answered today, Nicole has agreed to email some of those answers out to you. So thank you again for your participation. What does imbalance recognition mean?
Imbalance recognition, I think this is, I've got a déjà vu. Yeah, imbalance recognition is the, so it means the centrifuge can recognize an imbalance. So if your rotor is not loaded properly, and you might know the case when you do this because you're kind of in a hurry or whatever, then the centrifuge will start shaking a little bit. And if this is getting too much, the centrifuge can recognize it and then stop the run to kind of pull the emergency trigger, because if there would be a high imbalance and the centrifuge would run and run and run, the centrifuge can start to move, and we don't really want that, and we don't want to damage our motor shaft as well, which can happen due to imbalance too. So the imbalance recognition is there to protect you and your centrifuge from damages due to imbalance.
Great, thank you. Our last question that we're going to be able to answer in today's live webinar comes from New York City at Mount Sinai School of Medicine. We inherit a refrigerate centrifuge that has a lot of salt crystals. Do you have any specific agent we can use? We tried cleaning with water still dirt, but the water is still dirty. Also, if we use a centrifuge all the time at 4C, is it still recommended to keep the centrifuge open overnight?
Yeah, so it's kind of two questions in one. So firstly, salt crystals, I would maybe try, if you only use like a cloth, so try to use like a plastic scrub brush. And then you can, if you have salt crystals like in the boreholes, you can fill the boreholes with water and let them sit for a while. Or if it's more on the surface of the rotor, you can take like a moist cloth and put this cloth on the surface and let it leave it there for a while to kind of soak the salt crystals and get them a bit softer again, and then you can use your plastic brush to try and scrub it away. But yeah, actually the best way is to prevent salt crystals and residues with the regular cleaning. So the second question, so the second part again of the question was, Susie, can you repeat that? I think they wanted to know if they have the centrifuge refrigerated at 4 degrees, if it's okay to leave the centrifuge open overnight.
Yes.
Yeah. So, well, if you, a lot of people do this. They cool down the centrifuge to 4 degrees in the morning, leave it closed through the whole day, because then the centrifuge is always ready to go. This is something which actually shortens the lifetime of the compressor a little bit. So I would recommend to shut the centrifuge off in the evening and let it open overnight, because this will then help to prolong the lifetime of the compressor, because I don't think anyone's working there, hopefully, during the night. So it's better for the centrifuge to have like a break during the night. And when there's a little ice build up, which can be evaporate and dry overnight, it's also nice, because if it's moist and icy all the time, this can also lead to corrosion long-term run. And so yes, I would definitely recommend to keep the centrifuge open overnight. This is the best way to care for your centrifuge.
Nicole, thank you so much for your presentation today and for helping researchers across the world be safe. I also want to thank audience members for their amazing participation. Nicole, did you want to have any closing remarks before we close our webinar?
Well, no, just thank you for participating, and yeah, hope to see you soon, maybe on future webinars.
Absolutely. Thank you again, LabRoots, for making today's educational webcast possible. I want to let audience know before we go that today's webcast will be available for on-demand viewing through April 2018. You'll receive an email from LabRoots letting you know when this webcast will be available for replay. Please share that announcement with your colleagues who may have missed today's live event. That's all for now. Thanks for joining us, and we hope to see you again. Bye-bye.